Well, welcome everyone, and thank you for joining us for today's webinar. My name is Canario, and I will be hosting today's session. Today we are presenting the importance of truly secure Captchas by Pedro Fortuna, Jscrambler's CTO, and Kevin Goschalk, CEO and founder of FunCaptcha. We already see some people joining us. However, we will give another 2 or 3 minutes so that more people can join. So hang on with us, and we will start in a minute or two. Thank you. Okay, so our waiting period has elapsed, and now we can begin our session. And before we get started, and if you have any questions during the presentation, please type them into the question box that you can find on the right side of your control panel. We will answer them in the end of the presentation. If time runs out, we will answer the remaining questions via email, and you can also receive a recording of this session in your email as soon as it's over. Moving on to our speakers, they will be Pedro Fortuna and Kevin Goschalk, like I've mentioned before. Pedro is Jscrambler's CTO, and beyond that, he's a seasoned application security specialist, multiple-time speaker, and author of several patents in application security. Kevin Goschalk is co-founder and CEO of FunCaptcha. He is also a proud Australian, a speaker at Locomoco Sec and other AppSec events, and a pioneer of SLAs in anti-fraud tech. Regarding our agenda for today, it's pretty straightforward. We will start with Kevin, who is going to speak about FunCaptcha, their verification technology, and their approach to security. Then we will move on to Pedro, who is going to speak about Jscrambler and client-side application integrity, threats to client-side application integrity, protection layers, and then we will wrap things up with our Q&A. So I will hand the stage over to Kevin. And Kevin, hello, and the stage is yours.
Thank you very much. So I guess we can kind of all assume by our name that we're in the space of verifying human traffic from automated abusive traffic. We do that in a few different ways, which I'll kind of go into at high detail. And of course, we leverage Jscrambler for one of our many defenses that we use as part of ensuring client-side integrity. Some of the customers we're working with, we here at FunCaptcha have a pretty strong objective that we want to work with companies that suffer from truly sophisticated and aggressive abusers. It's not just kind of dealing with low-level bot spam like a WordPress website or anything like that. These are companies that are major enterprises suffering from huge multi-million-dollar fraud problems. And the attackers are extremely motivated and very well resourced and very intelligent and can do things that most vendors simply can't defend against and mitigate. So our technology is kind of constantly in R&D dealing with these really hard, sophisticated problems. And that's obviously for us the most exciting thing that we can be working on. We deal with sophisticated abuse across pretty much everywhere that you can think of from kind of a single funnel perspective. So for example, account takeovers is kind of a huge thing in the industry where you've got a login page and then, of course, the attacker is trying to get into someone's account so they can then do abuse within the account, stealing money, credit cards, taking their, private information, a whole range of different things once they can get in. And the way they go about getting into the accounts is they take all of these spilled credentials that are leaked onto the internet, the Equifax breach that had all the emails spilled. There's a whole bunch of these happening, every week. There's millions and millions of our own personal emails. We work with Have I Been Pwned, which is another Aussie, Troy Hunt, who is quite famous for making how apparent that these attacks are happening. And what they do is they take these leaked lists of emails and they pair it with the top 100, top 1,000 passwords. They don't even need to know your password. And they just go to every single website and they enumerate email and they enumerate password and they try and break in. And they're doing this in quite a sophisticated fashion. So what they'll do is they'll change their IP address on a per request basis. They'll bypass client-side fingerprinting by changing, what it appears their fonts they have installed and all these other techniques that allow them to kind of bypass rate limits. So what ends up happening is to kind of protect against account takeover, people are like rate limiting on the email itself. So if you get your account wrong 3, 4, 5 times, they actually lock you out of an account. And this is in itself becoming an attack that people are doing to kind of DDoS popular Twitch streamers and all kinds of things to prevent them from logging in and using their own personal accounts. We had a customer tell us that their CEO couldn't log into his bank account for 3 weeks because someone was attacking him directly and constantly rate limiting and blocking his account at the banks that he used. So there's limitations to kind of what you can do if that's you're reliant on technology as well. And then these same kind of approaches where they have these really sophisticated attacks can be applied across, all these different use cases. So auction house abuse, you can think of, auction marketplace where people are selling items. People are using bots to make sure they can buy things as cheaply as possible, similar techniques, so that it's very difficult to stop them. And they're able to just outpace humans. Blocking transaction is a really big problem in the airline industry, where we help customers like Singapore Air and HK Express, where they have competitive airlines that are creating software that goes through the booking process, gets to the end of the checkout process, and uses one of the payment redirection methods like Alipay or PayPal, which takes you off the website for 5-10 minutes, and it actually holds that seat while you're completing the transaction. And they never complete the transaction. And they have these bots, hundreds of thousands of them every minute, going through and reserving every single seat on every single flight route and actually eliminating that airline from being able to sell tickets. which is quite a problem, as you can imagine. Then we have chat spam, fake accounts, which is account registration, and then they typically use those fake accounts to go on to do all of these different kinds of abuse. The problem always kind of starts at the front door, where they're able to mass create accounts, or they're able to steal massive amounts of accounts, and then go on and do these other kind of abusive attacks. So it's always kind of a two-pronged problem. We ourselves deal with it in kind of two ways. So we have a risk-based scoring system that we leverage that lets us have a really good insight into, is this user or is the general traffic on our website in a particular area on that website abusive, or is it good traffic? And this is quite important because we don't want to be disrupting real user traffic. And in most cases, sophisticated attacks are targeted at trying to get through and break in. And if they can't break in, they actually stop. So you don't need absolute security at every minute of every day. You only really need it when these kind of spikes, or when there's this trend kind of switches from what appears to be real traffic across to these really sophisticated attacks. The whole point of using automation and bots is so you can do it at as massive scale as you possibly can, do as much damage in as short a possible time as you possibly can. And this is obviously something that we can pick up and determine without having to challenge that traffic necessarily on every single request. So we kind of have this telemetry aspect where we're looking at how are users interacting with pages, what's the general traffic trends, and all these other bits of telemetry that we look at on our individual customers' websites, but also across our entire network. So what's happening generally from traffic from Russia, what's generally happening from traffic from India, and these kind of trends let us determine, should we escalate and verify this traffic, and if so, then we can use our enforcement mechanism, which is FunCaptcha itself. And this is a piece of technology that we've been evolving over the last couple of years. We've gotten pretty sophisticated attacks against us. We've continued to develop and invest into our technology. We have never been beaten from a machine learning attack in the history of the company. We actually have an SLA guarantee on our technology. We're the only anti-fraud company that will actually guarantee and certify that our technology will stop these sophisticated attacks. And that's because, from our perspective, we're not really winning if we're only stopping a percentage of the problem. The only real way to make a spammer give up is ultimately to destroy the economics of what they're doing. It's not about being impossible to overcome, of course. In security and in technology generally, it's impossible to create something that an attacker can't overcome. We're all very familiar with this. But it is certainly possible to create something that it's far more expensive to attack it and overcome it than it is the kind of return on investment spammers and abusers and fraudsters can actually generate in return. And the kind of attacks that they can make, they range from various different things. It's not just, are we going to try like a machine learning attack against the Captcha technology? They'll also do things like brute forcing, trying to guess their way through it. And then another common Achilles heel is, well, if a human can get through the page, let's just use people to get through the challenge, and then we'll swap back to our bot and do the damage that way. So there's this kind of sweatshop problem, which Captchas are commonly known to kind of fail against. We ourselves have been able to prevent these kind of sweatshop attacks at scale. We have quite a different range of tools that we use to do this. You can Google FunCaptcha and sweatshops and how do I break FunCaptcha, how do I beat FunCaptcha, and you'll see people complaining about us all over these kind of forums about how do we bot and abuse websites that we're protecting. One of those defenses that we use is Jscrambler. So Jscrambler is quite interesting. I'm not sure if everyone here would be familiar, but we are all very familiar with Google's reCAPTCHA technology, the I'm not a robot checkbox, and more recently they start doing it without requiring the checkbox. When they first released this technology, they released it with a highly sophisticated client-side obfuscation tool that they themselves built at Google. Makes sense. I mean, the whole point of doing that is that to attack it, you have to be able to reverse engineer it, figure out how the code's working. and ultimately hiding it just drives up the cost, which is what we want to do to kind of combat these spammers and abusers. Problem with Google's code was it didn't adapt, and it wasn't morphing, and it wasn't changing. So it was always the same encoding and encryption in their client-side code. And ultimately what happened was within a couple of days of it being released, someone posted on GitHub the full source of how it worked and how to decompile it. Google reached out to them and told them to pull it down, but that, of course, was too late. I mean, the attackers already had the keys to the kingdom, and they'd spent significant time and resources building this engine. So, we looked at that and we decided, look, it makes sense to have something like that, but the effort to maintain and build something like that is just as much effort as it is building a challenge mechanism and a risk scoring system like we're doing anyway. And we don't want to be in the business of building client-side obfuscation and JavaScript encryption. It's a critical piece of our product, but it's not necessarily what we're good at doing. So we partnered with Jscrambler, and we have this feature. So we use Jscrambler in two ways. One is we protect our main code, which is just sitting across all of our customers' websites on a typical day-to-day basis. It's not highly obfuscated or encrypted. It is to a point, but it's something you could still reverse. And then we have a more advanced version that we can turn on as we need to. And this more advanced version uses all of the quite sophisticated anti-tampering techniques, site blocking, and a range of other things, which I won't go into too much detail about, that Jscrambler are quite well known for. And we have kind of keys that we encrypt into the client, and then the API itself changes so that when we turn this mode on, if you don't correctly render our JavaScript and can't correctly go through and leverage our technology in a real browser on one of our customers' websites, then the API will deny your input. So you just won't be able to input with it. And what this does is it means that an attacker can't just use curl or any of these other more simplistic headless browsers to try and bot us at scale. So they do this typically with a sweatshop attack, where you'll have the bot that will go and scrape the images from the CAPTCHA, and then the human will solve the CAPTCHA, and then the bot will submit the answer. We have other techniques that we attack this, but this is one where we've seen if you can eliminate the capability for them to use a bot as part of this, which basically means by leveraging this client-side encryption technique, they can't do that, so it's more expensive. We've actually seen that drive the cost to the point where they give up, in quite a range of really sophisticated attack scenarios. And it's from a user experience perspective, you see nothing different. So if you're just browsing one of our websites that we protect normally, it looks the exact same. There's no enhancement of the image mechanics. There's no enhancement of a harder challenge or anything like that. Challenge can be super trivial. All it does is enforces them to absolutely rendering the client-side experience as if they were an absolute real user. And this is just another tool that we use to kind of drive the cost up. So, like I said, there's kind of these two forks. We, through our build process, will always be compiling this code. We inject into it keys. The client-side code is always adjusting and changing. It's part of the polymorphic approach that Jscrambler uses, which means unlike reCAPTCHA, every time we deploy the code, it's entirely different. It looks different, it's encrypted differently. It also means that every time we deploy any changes, the keys are changing. So if someone were to figure out how to overcome our client-side obfuscation, encryption, then we would know, because we would immediately see a drop in traffic when we deploy a new set of keys. And we are now probably 14, 15 months since we first leveraged this in some of our more sophisticated attack scenarios. And we've yet to see someone figure out how to actually reverse engineer this process, which I think is very impressive, given we're all kind of highly skeptical, can client-side encryption really work? I think if you leverage the right frameworks and tools, I think Jscrambler is fantastic. And if you have the right mentality to how you want to leverage this as a defensive mechanism, you probably don't want to just rely on this solely, because if it gets overcome, then you're kind of left defenseless. But using it as a feature of your defense playbook, I think, is highly effective. So I would totally recommend that. But that's it from me.
Well, thank you, Kevin. That was awesome on your part, and it was a great glimpse into what FunCaptcha is doing. And now we will move on to Pedro, who is going to give us his part of this problem. Thank you, Pedro, and welcome.
Hi, thank you. Hi, everyone. Thank you, Kevin. I think it was very clear what FunCaptcha does and how Jscrambler helps ensure your verifications remain untampered. And I think that FunCaptcha is yet another example that nowadays more and more sensitive logic and data has to be on the client side. I think in the abuse prevention area where FunCaptcha is included, we have other examples like anti-cheating or anti-piracy, but there are also other plenty examples like proprietary algorithms on the client side, digital content that is accessed through the web. And in the digital advertising and e-commerce spaces, it's very common to have JavaScript monitoring or tracking, and they have a vital importance to supply accurate information to these industries. But these are some of the reasons why you need to have client-side application integrity, not all of them. But what is application integrity? You have application integrity when your application is executed the way it was developed. Its services and contents are only accessed by real users in an authorized environment. For instance, for FunCaptcha, it's important and relevant to know that all is happening on a real browser, not on an automated bot engine. And finally, you have integrity when your technology is being used in strict compliance with its software license. Now, in security, defense in depth is always the best answer. And client-side integrity is best ensured by combining different protection mechanisms, like, for instance, FunCaptchas and Jscrambler's code integrity. And Jscrambler itself follows the defense in depth model, as it offers a number of layers of security to your code in order to raise the bar and make it extremely hard for a malicious user to attack or tamper with the client-side logic of your web application. So how do we do that? With Jscrambler, you can protect your client-side code by concealing applications inner workings, like any algorithm or technique that you want to keep hidden, by protecting abuse prevention mechanisms or other types of add-ons that are useful for your business, be it analytics or advertising, and that you want to make sure that are working properly. By enforcing licensing agreements to make sure the application will be executed in the expected environment and by authorized users only. By safeguarding the user experience, making sure that your UI and the way that you communicate with your users is not tampered with, and by preventing competitors or hackers from stealing your IP, be it to reuse it or to just tamper with it without permission. So to protect the code of the application, we rewrite its codes, and this happens in build time. So when you deploy already protected source codes. We use 3 different techniques when transforming the code, and the first one already mentioned is obfuscation. We are the only solution that offers the most advanced JavaScript obfuscation techniques that, combined with polymorphic behavior, transform your JavaScript code into a form that is protected against reverse engineering using automated static analysis attacks. And by the way, obfuscation should not be mistaken with minification or uglifiers. Those are only meant to optimize the codes. They do nothing to protect it, and they can be reversed with simple tools found online. But sometimes we feel that people mistakenly confuse optimizers and uglifiers with proper JavaScript obfuscation. So here in this slide, you can see an obfuscation example. On the left side, you can see the original source code with everything very neatly indented, source code comments, readable strings, and all the meaningful names, variables and function names, and everything has a clear structure, and control flow is easy to read. And on the center, you can see an obfuscated version of that, which is much harder to read. And I mentioned a version because since our engine is polymorphic, if we generate a second version, it would be, as Kevin mentioned, completely different version. So for your convenience, we also present to the right a beautified version of the obfuscated code, where you can see that all the names and strings no longer make sense, and the control flow is completely different. So it's very hard to understand what's going on in this example. The polymorphism is an important aspect to it because even if you reverse a single version of the obfuscated program, it won't help you next time, in the next time that you target the code. So this creates sort of a moving target for attackers that raises the cost of doing the attack. But what you're seeing is just the first technique, the obfuscation. We actually go beyond that. The second layer is installing code traps in the code. So code traps is extra code not present in the original source code that enforces something about the way the application is executed. So you may want to control in which domain the application is executed, or a list of domains. You may want to control when or between which dates the application should execute. And you can also control the environment, either the browser where it should run or the operating system. If we detect something is off, you can react, like, for instance, breaking the application on purpose. Or you can use another type of countermeasure that I'll talk about in a minute. So it's also important to understand that these traps are very resilient. They are instrumented throughout the code, leveraging the obfuscation, and are applied to different shapes and forms so that it's hard to recognize and to remove them all automatically using static analysis. In the third layer of defense, you can also make your application self-defensive. So your applications become able to detect tampering, debugging, or poisoning activities. If any of these activities are detected, again, the application is able to react. It can derail the code execution, and this is done to prevent the attack from being successful and creating a lot of frustration for the attackers. So, and this protection is also completely self-contained in the codes. It doesn't have any external dependency. It doesn't check with a service somewhere. It's completely built into the code, and it's a very organic defense. With Jscrambler, if any attack is detected, like I said before, we can launch a countermeasure. The most common one is breaking the application. But you can also have a more stealthy reaction, like executing a custom callback on the client side. Sometimes you don't want to warn the attackers that you are basically seeing what they are doing. You can delete cookies. You can redirect to a certain URL. And these are some of the things that you can do when you detect something is off. In this slide, you see what could be a standard code transformation set for your use case. In reality, there's not a single cocktail of code protections that we apply to all the applications. This is the work that we do specific to each application. We help the application developer finding out the best settings for their specific application, and of course It's when we capture Jscrambler's application security team vast knowledge in protecting all sorts of JavaScript-based applications. Deploying Jscrambler is actually very easy. You just need to call Jscrambler from your build process, and you get a transformed code in return. So usually the code follows the rest of the normal deployment workflow, passing through QA to deployment, to all the deployment processes and running all the tests. And in fact, you don't need to change how you code your application. Your developers don't even need to know that Jscrambler is being applied to the application. So this is all very convenient in terms of the impact that it can have when bringing Jscrambler to your organization. So transforming the code always has the potential to impose a performance impact and file size growth. But it's important to know that with Jscrambler, you can fine-tune the protection on different levels. First, there isn't really an average performance impact that I can quote, like generically. It really depends on your specific application and its source code. But what is important to understand is that this impact is easy to manage. With Jscrambler, you can use code annotations to enable, disable, or customize transformations to the smallest level of granularity if you want. And this allows you to optimize performance, tweaking the parts where performance is most critical and increasing the resilience in parts that are more security sensitive. You can also use source maps, which maps obfuscated code to its original source code, and this helps you get through the debugging process and optimization. But if any problem arises, we have a team of application security experts that can jump right in and help you. So concluding, there's too many ways one can mess with the logic and the verifications that are done on the client side. And you need to deploy client-side protection mechanisms to raise the bar for attackers for making tampering or fraud so complex and costly that it becomes economically unviable. And this might mean that you need to use resilient Captcha that ensures that the user is using a real browser, among other verifications. And that also means that using a tamper-resistant polymorphic JavaScript protection in all your JavaScript. And this, be it your proprietary logic, your ads, your security solution, or any other parts of your online presence. So dealing with the ever-changing landscape of sophisticated client-side attacks shouldn't be your concern, as Kevin mentioned. You don't need to worry about if protections are running smoothly across every browser and every JavaScript engine, and we all know that this might change every day. You should focus on your business and trust FunCaptcha and Jscrambler to do its job and to do it well. FunCaptcha and Jscrambler are easy to deploy and to integrate, and you can get it running pretty quickly. To get it started, just head off to either FunCaptcha.com or, in our case, to Jscrambler.com and initiate a trial. And this is all I have. Thank you.